everyone, what is going on? Welcome back to another video here on the channel. In today's video, I got an exciting one for you guys because you guys said you can get these specific battery packs on Amazon and they actually perform quite well. You should check them out and at least share some of the data that I am able to collect. Well, I ended up doing that, and I can say that these battery packs are actually the very first time that we've passed the test. We did not overheat the packs for the duration of the batteries test. So that is really good news. What I want to do is I want to break down the process. We're going to go through the tests that we normally do, which is based off of the charger. We get internal resistance. Then we're going to dive into actual performance test where we load the battery packs at around the 105 amp mark, and we're going to record some battery performance parameters that we achieve with that specific test. Then what I want to do is I actually want to compare these batteries, if they would be good in a radio controlled speed run type vehicle, what would the data say for these versus packs that we've tested in the past were actually larger in capacity but not necessarily as good in performance. We're going to see and use the data and then come up with a theoretical what we should expect from these packs if we ran it in the exact same setup. We're going to do that closer to the end of this video, which is going to be quite interesting, being able to see what the difference we should expect would end up being. So these are the packs that I've pretty well tested all day here. These are CNHL G Plus packs, 5,000 milliamp hour. They are 4S and rated at 70C. These should be pretty high performance considering the specifications that we have here on this battery. Now, one of the advantages that this pack has over some of the ones that we've tested in the past here is capacity. This is the first 5,000 milliamp hour battery that we're testing. However, when we use the Patreon RC calc sheet to predict the performance that we would get out of this in a radio controlled car, in the application of actually using a radio controlled car, we're going to compare this pack against even a higher capacity battery. And that higher capacity battery, I can tell you already that it did not perform as good as this pack did. Let's get into it and let's start off by showing the resistance there of these cells. So as you're taking a look here, I got a couple things that I do want to talk about. I'll probably make a video and then go in a little bit deeper than what we're going to describe in this particular video, but I try to make a couple things consistent. And that is, of course, the charge rate relative to the capacity. I do like to use a 1.5C rate to just charge the battery pack, and that's where we're going to take our internal resistance measurements. I like to keep the temperature of the room and specifically the batteries within half a degree, and that's plus or minus half a degree actually. So I'm a total range of 1 degree Celsius. I can't remember what that number is off the top of my head. I have to look it up every single time I literally do this test, which is funny. And then the other thing that I like to keep consistent with this is I'm taking the resistance measurement at the 1 minute mark, and those are the values that I'm taking. And right from there, what I ended up doing is I charge it for the remainder of the battery's pack's capacity right up to 4.200 volts per cell. And from there, I'm running out to our performance test that we can get into. However, just before we get into that, what I want to do is I want to show the actual calculated C rating based on internal resistance as we've done it here in the video. So right here, what I've done is listed out all the individual cell resistances. On the bottom right, I have an average of 1.4, and using this RC Patreon calc sheet, what I can do is I can actually take this average of 1.4, put that in as the internal resistance here, 1.4, and then I want to put the capacity of the pack as 5,000. When you do that, the battery pack's calculated C rating actually comes out to 29.9C, and the maximum continuous current with the 29.9C comes out to 149 amps. Those numbers are pretty good. However, we have learned more recently that this calculator does overestimate the maximum continuous current, thus the actual calculated C rating. So the actuals are a little bit lower than what they're specified here. Let's continue. So you can see the image right there. What we can see right from our graph is that it looks a little different than what we've seen in the past. What we would typically see in the past on the last couple batteries that we've tested was the curve would start out nice and high and then it would actually go and drop off and then climb a little bit and that's because the cells are starting to heat up. Where this specific test, the cells did heat up, and I was watching it right through live as the test was going on, and it didn't provide more performance as they heated up. So what I do draw as a conclusion is that there is a subtle difference there in how these packs react to the temperature gain that they're actually seeing as they start to warm up under load. The total milliamp hour of the CNHL that we're able to pull out of it was 4518 milliamp hour. Now that's pretty good. It's a 5000 milliamp hour pack, but what this tells us is we're going to actually get over 4500 milliamp hours from it, and that's at a 105 amp load. It actually is a higher load than any of the previous tests that we've done. Now the milliamp hour to 3.50 volts was 1780, and the time to get there was just over 60 seconds. This is in fact a lot better than previous tests that we've done, especially if you were to compare against the HRB pack that we did have. That was at 30 seconds half the time, and then the Liperior was at the 43 second mark. Now the milliamp hour to 3.6 volts, this was at 765. It took about 25.5 seconds to get there, which is a lot better than both of the two tests that we've done here before on the HRB and the Liperior. Voltage that we ended up seeing at the 10-second mark was 3.67 volts. This is actually 0.1 volts higher than the previous two tests that we've had. And then the energy per cell in terms of watt minutes was 955, where previously, because of the smaller capacity, it is going to be lower for the HRB and the Liperior that we tested. However, the average cell wattage is going to show more about the performance that it can deliver on the spot. And that was about 360 watts on average throughout the duration of the battery pack, where before we saw about that with the Liperior, which was pretty good, and then we saw with the HRB that it was at 350. Unfortunately, we don't have it with the Zeee battery packs. I ended up getting rid of them prior to us being able to capture any of this data because I didn't have this test bed set up for us. Now that we've gone over that, I want to show you the difference if we ended up using these battery packs, these CNHLs, versus the Zeee battery packs that we originally tested when we kicked off this battery testing sort of series here on the channel. Let's go ahead and do that. All right, guys, this is the Patreon site for the RCexplained community. If you do decide to support the channel, you will then have access to the calc sheet. We are in December right now, where version 1.022 is released and ready to download. Next month, we're going to have a version 1.023, and this version will no longer be able to be downloaded. So you do have to make sure you're downloading within the same given month. I'm going to have a new post for each month that we end up releasing a link to. So let's jump over to our spreadsheet because I think this is going to be very fascinating. So this largely represents my old and / my new Limitless V2 build, where we have a 27 tooth pinion, a 45 tooth spur gear. We got the 8-cell 2400 kV brushless motor in there, and then I've selected load factors and load currents that very closely match what's happening in my Castle Creations data log. So now what I can see is this actually pumps out a speed 216 kilometers an hour, which is exactly what I was able to hit. And I did have to adjust parameters a little bit in order to get 216 to match. So what I want to do here is take a look at the Zeee battery pack that we use. That's saying 4 milliohms. I'm going to jump that up to the current mark if we use those packs that we did here in the video. And that was 1.4 milliohms. So as soon as I put 1.4 milliohms, the speed actually jumps up from 134 miles per hour to 170 miles per hour. That's absolutely bonkers in terms of the amount of performance that we potentially could gain. Does this mean this is how fast we would go? The answer to that is absolutely not. Why? Because at a higher speed, we are going to see different load factors and we're going to see a different loaded current at speed. So let's assume, because we don't have the data at this type of speed, that we're going to see probably closer to about 500 amps. And another point here, at 500 amps, the load factor is probably not going to be 5%. It's probably going to start to climb into the more heavily loaded motor here. And what we can do is we can change this load factor to, let's say, about the 10% mark. And this is going to give us a new potential speed of 150 miles per hour. So just the battery's performance here is going to give us a potential 15 miles per hour. That is substantial. That is significant. significant, but also is that resistance difference. 4 milliohms to 1.4 milliohms is a massive change, a massive difference. And there are batteries that are even better than this, so we can potentially go even faster here in the future. I can't wait till next summer. Hopefully I can find a different spot to run the V2 Limitless, because I do want to start to see speeds that can exceed some of my jets and what they're capable of doing. Well guys, there you go. You guys recommended these battery packs and you were right. These battery packs perform very well. 5,000 milliamp hour, 70C. They're pretty good for the price and they're readily available right on Amazon. At least here in Canada, I didn't have a problem getting a hold of them. What I really do like about this, it doesn't show up in any of our metrics, is that these actually measured very close to one another, both in internal resistance as well as the performance data that we were able to capture. The data that came between run 1 and run 2 were very similar, and I really appreciate that with packs. I did not see that on the HRBs. The Liperior was a lot better, but not as good as these guys. So I'm really impressed with the price of these, the availability, and the performance that we get out of them. Does this mean that this is the best battery out there? Absolutely not. These are not going to be the best batteries that you can get. However, if you want something quick that can perform, these are going to do pretty good. I can't wait to try them in the summer and get these into some speed run vehicles and maybe even some speed run airplanes and see what these guys can do. Hope you enjoyed this video, guys. If you want to help and support what we're doing here with the battery performance test, I'm going to leave a link in the description below. As always, like the video if you did. Don't forget to hit that sub button, guys, so that I can see you in that next video. Thanks a lot for watching, and have a great Christmas holidays. See you guys.